CCL, but let's get going here. So I think most of you folks have been here, but welcome to anybody who's new. As you all know, Green Drinks is part of an international organization that brings together folks. Delaware now, since COVID, we have been doing it virtually, which seems to work well because we have folks from up and down the state. We're a nonpartisan educational gathering, and we invite everybody wishing to explore and share and discuss environmental issues. I guess everybody's registered. They know how to do that. On the email that goes out, you can find recordings of this. You just saw Dee say we're being recorded. So we have partners, Sierra Club, Delaware chapter, the Citizens Climate Lobby. Thank you all. I'm also a member of that. So we are well represented this evening. Plastic Free Delaware, you just heard from Dee about the Yes conference coming up next Thursday, is that right? The Delaware Native Plant Society, Interfaith Power and Light, DEVA, you heard about that from Charlie, and Power, People for Offshore Wind Energy, and several folks are members of that, pushing, and I guess we should be getting some legislation on offshore wind coming up. So I think that is all I need to say about that. So, drum roll. I am exceedingly excited to introduce Jen, who joins us with a passion for environment and human health. What a wonderful, wonderful combination. She's the head of the lab operations and services with PFAS solutions. And again, thank you to the Steve and Audrey Like for connecting us with her. Before that, she was a graduate research assistant at the University of Delaware. Before that, a laboratory assistant. You can see she's climbed up the ladder. She graduated from the University of Delaware, first with a degree in, I lost that piece of paper, hang on a second. And I think it was environment and environmental studies. And now with a master's degree in plant and soil science. So without further ado, Jess, you want to take over? And if you need to screen share, Dee will do that with you.
Okay, great. Thank you. Thank you for the introduction. And it's nice to meet you all. You guys are all doing very impressive things. Let me just get my presentation up. Sure. If I have do you guys see my notes? If I have it this view?
We don't see your notes. I think you're good.
Oh, okay, great. Great. Awesome. So I'm Jess Anton. I work for the Center for PFAS Solutions. We're a nonprofit 501c3 organization located in Newcastle, Delaware. We're a tiny lab. We were started in December 2019 with just 2 full-time employees. I want to mention my coworkers, Sitha Coleman Kamula and Chuck Pally. They're really the ones who started this organization and the whole reason I have a job. They worked for about 1.5 years, and then I started the company. I've been there for 3 years now. And now we have 5 full-time employees and 4 part-time employees. So we're really growing. We've grown a lot in the last 4.5 years. And all of us are dedicated to solving the issues that arise out of PFAS. And it's really nice to work with people that are very compassionate about public health, as well as very knowledgeable about PFAS and chemistry in general. I learn a lot every day. So it's nice to work there, and it also feels nice to work towards solving a issue, a really big issue. So what we do a little bit about PFAS solutions is that we have a services side, meaning that we test drinking water for anyone who wants their water tested, whether it be a homeowner or a water company, water providing company. But we also have a lot of research projects because we're a research lab. That's our main focus is research, that we do provide services to the public. So most of our research is focused on finding, detecting PFAS compounds, as well as finding solutions to the problems that arise, such as filtering it out of drinking water or wastewater. So we're trying to develop technologies that detect and also get rid of PFAS from drinking water. So the topic of this presentation is in the news in our top water. What is PFAS and why is it everywhere? I wasn't sure everyone's background, so I tried to keep the presentation relatively simple, or like the basics of PFAS, because I wanted everyone to be able to understand terminology that is in articles a lot of the times now, and kind of understand the basics of why PFAS is just now being discovered as a problem and what makes PFAS a problem, different aspects of it. So I'll begin the presentation with kind of like a case study of a contaminated area located within Delaware. And then I'll go into kind of the general basics of PFAS chemistry, various traits that are associated with those chemistry traits, and a little bit of the history of PFAS use and production, the health impacts, where PFAS are often found in high concentrations, and I'll also talk a little bit about the current drinking water regulations that exist in Delaware and the US in general. And I'll talk a little bit about what you can do in the meantime while the regulations kind of lag behind. And then I'll end it with two resources that I think are really helpful to have for the general public. So one extremely contaminated area in Delaware, but also the US, is Newcastle, Delaware, which is where our lab happens to be located. A little bit of a coincidence, but also it's now designated as a Superfund site, 5,000 acres in Newcastle, Delaware. And it's designated as a Superfund site due to PFAS as well as some other contaminants. And within the 5,000 acres, it includes the National Guard base, the airport, multiple landfills, businesses, as well as homes and schools that are all throughout the area. So all of that 5,000 acres are now designated as a Superfund site. In 2019, the CDC did a national exposure assessment in which they tested, I think about 200 some people, their drinking water, blood levels, and the dust in their homes for PFAS. And what they ended up finding was that in the blood of Newcastle residents, PFAS was 9.8 times higher than the national average for some of the PFAS compounds. Currently, the water is filtered and meets all regulations. I just wanted to say that that's really important to know. Now, the water is filtered and it's meeting all regulations. And it has been filtered since 2015. But we've all heard that PFAS are deemed forever chemicals. So I want to kind of call back to this Newcastle site as we learn more about PFAS in the further slides. So what is PFAS? PFAS is a chemical acronym for per or polyfluoroalkyl substances, which again, what does that mean? organofluorine compounds. It basically is a compound that has carbon and fluorine bound together. And there's other compounds that are considered organofluorine, or even compounds that contain fluoride. But the fluoride added to drinking water is not the same as organofluorine because it does not contain carbon. So it's generally of not concern. What I'm talking about today are carbon and fluorine containing compounds. There's some other organofluorine compounds like pharmaceuticals and ag chemicals. But again, they're a different group of chemicals because PFAS has more fluorine, or sorry, it contains more fluoride than these other compounds like pharmaceuticals and ag chemicals. So they're categorized as separate than those other compounds. So when I say PFAS, I'm talking about a group of chemicals. There's thousands of different combinations of these, up to like some people say 10,000 different types of PFAS. And what makes them different is different combinations of aspects. So one important terminology that you might hear is carbon chain length. And what that means is in the molecule, you have carbon linked together, kind of like a chain, and then you have fluorine bound to the carbon. So you might hear terms like short chain PFAS or long chain PFAS. And these are important to understand because you can have different traits associated with them. And I'll get into the traits a little bit later, but short chain basically means that you have 7 carbons or less linked together with fluorine bound to the carbon. And long chain means that you have 8 carbons or more linked together and bound to fluorine. And that's all that means. But another difference you can have is other atoms attached to the molecule as well. You can have other elements. So in addition to carbon and fluorine, you could have hydrogen, oxygen, sulfur, or phosphorus, and these would make different types of PFAS. Again, I'm explaining these differences because the differences make them behave slightly different. So it's really hard to regulate a group of compounds when they all behave very differently, depending on these small changes in the molecule. So when I say PFAS, I'm talking about the group. If I spell out a certain type of PFAS, I'm talking about a specific type of PFAS. So if I say PFOA, I mean perfluorooctanoic acid. And if I say PFOS, I mean perfluorooctane sulfonic acid. These are the 2 most common compounds that you hear about. And it's because they're the oldest, or at least they were used more predominantly in the past, and they've been phased out of production in the US and use, at least intentional use in the US. And so that's why you'll hear a lot of media about just PFOA and PFOS. But when you hear that, they're only talking about 2 different PFASs when there's thousands of other ones that exist. And they're both long chain. So that's important also to know, is that both of these compounds are long chain PFASs that have now been phased out. And that's important because it was originally thought that long chain PFASs are more harmful than short chain. So they were phased out and substituted with short chain. But I'll get into that a little bit more in the further slides. Some advertising that you'll see on products is that it's PFOA free, or sometimes you'll see PFOS free. If you see it's spelled out like this, that's not a guarantee that it's PFAS free, like organofluorine free. It just means that it's that specific PFAS free. So you want to look for advertising that says PFAS free, if you want products that are organofluorine free. So I wanted to talk about some of the traits associated with PFAS and why they're such a problem. The reason they're such a problem is because of these traits. So the first one is that they're very persistent, meaning that they're very strongly bound. The carbon and fluorine bonds are very strongly bound. They don't break down in our bodies. They don't break down in the environment. It's just not very efficient for any microbes to break carbon and fluorine down, so they just don't do it. And they're also resistant to heat and incineration, so they're difficult to clean up. And PFAS are also very pervasive, meaning that they go everywhere. Basically anywhere that water travels, PFAS can travel. So it can travel in the air, it can travel in water, it can travel into the soil as water migrates through the soil, and eventually into groundwater. PFAS are also bioaccumulative, which is something that means that it builds up in anything that consumes it. So it could be accumulate in plants, humans, and other animals. Basically anything that uptakes the PFAS will have the PFAS in them. There's various half-lives for all the different types of PFAS that exist. They're all very different, and they all behave differently in the body, the human body, as well as other animals. Like a fish might bioaccumulate PFAS differently than a human, which makes toxicity studies a little bit different when relating animal studies to human studies. This is why Newcastle saw so much PFAS in their blood, is because they were drinking contaminated water for years, and all of that PFAS accumulated in their bodies. PFAS can also biomagnify, meaning that it builds up the higher up in the food chain you go. So say grass consumes water from the soil that contains PFAS. So now the grass has PFAS in it, cows consume the grass, and then humans consume the cows. It kind of funnels all the way up to humans, and we're left eating from contaminated food, possibly, and possibly having the highest amounts of PFAS because of all the contamination that we're eating. So where did PFAS come from? In 1938, DuPont invented a product called Teflon. A lot of people have heard of Teflon. It's like nonstick pots and pans and things like that. They're really convenient for cleaning. Another name of it is like PTFE, which is like a fluorinated plastic. So it's not a PFAS, but it contains PFAS, and that's why you saw some people concerned about the release of PFAS when you cook food using Teflon. In 1952, 3M invented Scotchgard, which is like a textile product that coats textiles for water, oil, and stain resistance. And within that product, it contains PFOS. And after that, a range of different consumer products used PFAS for its stain resistance, waterproof, and also insulators. In the 1960s, late 1960s, the US Navy and 3M invented light water, which is a firefighting foam called AFFF, which is aqueous film forming foam. It's like a military grade firefighting foam that can be used for fuel fires. So we've had years of PFAS use because PFAS is so incredibly useful. They're highly resistant to degradation, which makes them more ideal than other compounds, such as in firefighting foams, in these high heat fires, like fuel fires. Fluorinated firefighting foams are resisting breaking down under that high heat, so they're able to put out the fire better than anything that had been used previously. So PFAS are very useful and still remain incredibly useful for a range of different uses. So it's just really unfortunate that PFAS are being discovered as bad for us. And there being so many different combinations makes it really difficult to ban one when there's so many different uses for it. But there's still, some of them are being discovered that they're bad for us. So the toxicity data on PFAS is very slow moving because there's thousands of them, and it's difficult to relate animal studies to human studies. So you'll notice in this chart, there's only about 5 different compounds mentioned, and that's what the CDC has good understanding of what the effects of these specific PFAS are causing in humans. So they could cause increases in cholesterol levels, changes in liver enzymes, decrease in infant weights, including lowering antibody response, especially in children for some reason, and pregnancy-induced hypertension and various cancers. So the response to these health impacts is very slow. A lot of people ask questions like, what's going to happen if I have consumed PFAS for years? And the problem is we don't really know, unfortunately. And I've heard people say, just to make sure you get your cancer checks up to date and talk to your doctor. But doctors also don't know exactly what to say either. But we do know that screening, cancer screenings, keeping up to date with that is definitely very useful in preventing cancers caused by PFAS. Okay, so how could you be exposed to PFAS? I've told you what PFAS is, all the bad things about PFAS. So it's might be a little bit overwhelming, but there are ways that you can avoid PFAS. So one of the biggest exposure routes for PFAS is contaminated drinking water. You can also get PFAS exposure through food packaging and cosmetics that use PFAS. If you work in a field that uses PFAS or manufactures PFAS, you're also at a much higher risk of exposure than the average person. And also if you're living near a PFAS emitting facility, for example, Fayetteville, North Carolina, there was a Chemours facility that was releasing a PFAS compound called Gen X into the air and into the wastewater that they were releasing into the stream there. Now that I don't know if you've seen the news, but there's been a lot of litigation there, and Gen X is being filtered out. So luckily they've resolved that for now. Some major potential hotspots, especially in the US, are military bases and airports. And this is because of historical firefighting training. So when, in addition to putting out fires, firefighting foams that are fluorinated were used for training exercises. And so every time they trained, this fluorinated foam would go into the ground and into the groundwater, and build up over time. And that's exactly what happened in Newcastle, Delaware. There's an Air National Guard base as well as an airport in the same location that had historically been doing the mandatory firefighting training that is required. But unfortunately, they were using fluorinated firefighting foams. And over time, that PFAS in the foam built up in the drinking water in Newcastle. Other potential hotspots are industrial facilities making PFAS or even just using products that contain PFAS. There is another example in Delaware, in Blades, Delaware. I don't know if everyone remembers a couple of years ago, there's a chrome plating facility in, I think it's in Lower Delaware, but they were using PFAS for a fume suppressant, which is like a normal part of chrome plating. And unfortunately, it contained PFAS, and so it went into the groundwater. Now, Blades, Delaware's water is being filtered and meets all regulations. So luckily that has been resolved as well. But that's an example of a facility unknowingly contaminating drinking water because of the normal procedures for different industrial facilities. A lot of companies don't know that they're even using PFAS or that what they're using contains PFAS, so they don't know that they're a potential source. Wastewater treatment facilities are specifically not a source of PFAS, but if they receive waste from facilities that are using PFAS or making PFAS, their waste stream now has PFAS in it, and wastewater treatment facilities are not equipped right now to handle PFAS or remove PFAS. So basically what comes in goes out. So most wastewater treatment facilities are more equipped for excess nutrients to make sure that algal blooms don't happen after their waste is released. So they're just not equipped to handle PFAS that are really hard to degrade. So currently there's no federal enforceable drinking water limits for PFAS. There are something called health advisory levels, which are non-enforceable, but they're kind of like recommendations. Previously, there was a health advisory limit for PFOA and PFOS, which was set to 70 ppt, which is parts per trillion, which is still a very small amount. 1 parts per trillion is like 1 drop of water in an Olympic-sized swimming pool. So it's very, very small amount, but 70 ppt was still deemed too high. And in 2022, there's a proposed limit that was released of 4 ppt for PFOA and PFOS. The EVA also released health advisory levels for 4 other PFAS, including Gen X, PFBS, PFNA, and PFHXS. So these include both long chain and short chain compounds. Some of these included are actually substitutes for PFOA and PFOS. So they were, when PFOA and PFOS were phased out, Some of these other compounds were used more predominantly in place of PFOA and PFOS. So it's really interesting that now they're being recommended to be very low concentrations, as well as these other two, PFOA and PFOS. Some states do have their own limits set that are enforceable within their state. Right now, Delaware is waiting for the federal limits to be set, and then they'll take those limits as their own. They were in the process of setting their own, and then the EPA released these standards that are actually lower than what the state of Delaware was proposing. So now Delaware is just waiting for them to be official, for them to implement them. Previously, Delaware, all of the water systems met the previous limit of 70 ppt, and now most water systems are trying to meet the new limit, proposed limit of 4 ppt. New Jersey and Pennsylvania already have their own enforceable drinking water limits, which are actually higher than this 4 ppt limit. So they would have to adjust down once the federal limit has been set. After the EPA releases their own limit, every water company would have 3 years to comply. So they would have 3 years after this has become official to meet that standard. So what can you do? Right now, I'd recommend having your water tested. I don't want to promote my own company, but there's lots of other places to get your water tested. But especially if you have a private well, you should have your water tested for PFAS. That should include those 6 PFAS compounds that are going to be regulated. You can have different concentrations of PFAS from home to home, depending on like your well depth or how much water you're pulling up your well versus your neighbor. You might have different amounts of PFAS coming to your tap. For public water, you could even pool funds in your neighborhood if you all get your water from the same source. So that's a benefit of having public water, is that you could just test one person's home and it would be generally the same for everyone that has that same water provider, as long as they're getting it from the same source area. But private wells, they should all test individual wells. When you get your test results and you find that, if you find that there's PFAS in it, the typical filter that's recommended is a carbon filter. Historically, that's been what has been proposed for PFAS removal. But as I mentioned before, is that there's short chain PFASs, meaning they have 7 carbons or less. Those kind of just go through filters a lot more quickly than the long chain PFAS. So you might see filters that say that they'll remove PFOA or PFOS, and those are long chain compounds, and those do get removed pretty well with carbon filters. But the short chain compounds kind of seem to go through the filter a lot quicker, and you'll see them come through the filter before those long chain carbon PFAS compounds. What I would recommend would be getting, if you find PFAS in your drinking water, to get it under the sink, reverse osmosis filter. And this would remove all PFAS, as long as it's maintained properly. It would remove short chain PFAS as well as long chain PFAS, so you'd be covered in that aspect. And it'd be a little bit more pricey than a carbon filter, but you might be able to go a lot longer than replacing the carbon filter. Another way to reduce your PFAS intake would be to reduce your packaged food or fast food consumption, because a lot of oil-resistant food packaging contains PFAS in order to make it that oil-resistant, such as microwave popcorn bags. They're usually very loaded with PFAS because they're oil-resistant. So unfortunately, popcorn bags do contain usually PFAS. I can't say that for certain, but that's what the research is showing. Another way to limit your exposure is to limit your use of cosmetics, especially anything labeled waterproof or long-lasting. Again, I can't say for sure that a product contains PFAS just because it says waterproof, but that's also what the research is finding. These properties of PFAS, which are great, are now being used in consumer products like waterproofing your mascara. And if you're putting it directly into your eye, there's a high chance that it gets into your body through your eyes. And the FDA only minimally regulates cosmetics, so I don't see any changes to this very soon, at least as not as quickly as drinking water regulations. So I don't know if I have time to get, these are two resources that I wanted to show you all. The first one is kind of just like a overall really good resource for PFAS facts and information. The second one is actually a tool that the CDC released that you can kind of estimate how much PFAS is in your blood, and it gives you recommendations of what to talk to your doctor about, and some pamphlets even to give your doctor if they don't know much about PFAS. Am I able to can I show you all this tool? Is there enough time? I think you're muted, Jen.
I didn't hear what you said. Is there time? Yes.
Okay. Then I will, let me stop sharing this.
There.
Yeah. I'll pull the link up in just a second.
Great. Tell me when you're ready.
Okay. I'm sharing it now. Can you see the CDC website?
Oh, yes. Okay.
Okay. So this is where the link I posted on the slide takes you. If you scroll down, there's a button that says launch tool.
Okay.
It kind of asks you a few questions, and it estimates how much PFAS, these specific PFAS would be in your blood. So this one is asking, do I know how much PFAS is in my tap water? I'm gonna say yes, because I have tested my water.
Okay.
Does your tap water source have a treatment system installed? I do, but I'm gonna say no, because I just got it like last year. It's asking what concentration, but if you don't know this, the concentrations, you can also have it estimated by your zip code. I live in Newark, and it estimates these concentrations for drinking water in Newark. But I have the numbers right here, so I can show you. Depends on how your results are reported, but I'm gonna go with parts per trillion because that's
Okay.
what usually is reported. You might also see nanograms per liter, and that's the same as parts per trillion. Let's see. So they only want 4 different compounds. So let me just see. This was water from my own house. Probably about like a year ago. So I'm not
Okay.
sure what it is now, but. Let me just stop sharing for now. It's asked you like a few personal questions. So I'll show you that in just a second, once I get it through. It asks you your birth date, your assigned sex and your weight, and how many children you've breastfed in the last 5 years. Because all these things affect how quickly you would turn over PFAS in your blood. And let me share my screen again. So this is the next page. I don't really drink bottled water. I drink mostly from the tap, filtered now, but not really much bottled water. And I haven't changed how I drink. So it splits it into different compounds. So to start with PFOS, it says that my estimated levels are 3.39 micrograms per liter, which is parts per billion. And which is similar to that most of the people in the US. So if you remember in Newcastle, I said their PFAS concentrations in their blood were 9.8 times higher than the national average. So I fall within the national average, basically. And you can also see where you fall for other compounds. And I fall also within the national average. But yeah, that's just a really good tool for estimated. Unfortunately, it does rely on if you have your water tested, because I tried searching all areas, they don't have every zip code, all the data for every zip code. So you may need your drinking water PFAS data.
That's fascinating. Thank you. Thank you. So we can check this stuff out. Which is better for you if where's that? I have to find the chat. I was just trying to look at these questions. James, what was your question? You want to, I don't understand here. Which regulations?
So let's, so thanks for the presentation, Jessica. You had mentioned a few times that we're up to all regulations at this point because like water in the city, for example, is being filtered. I'm just not sure what those regulations are. I'm also curious how much it costs to have water tested by your firm or some other on average.
Right. Yeah, so I think a lot of times the phrase meets all regulations is used, even though there aren't any current regulations. What that means for Delaware is that before 2022, it meant that the water didn't contain more than 70 ppt of PFOA or PFOS. What that means now means that it's filtered down to 4 ppt, but that's still not official yet. So not all of the water companies are meeting that, but they're trying to. Your other question, what was your second question? I'm sorry.
Second question was, on average, whether it's your firm or another one, how much does it cost to have water tested?
Right, so the PFAS testing is very expensive. It's not really something that's super available for the public to just get their water tested, unfortunately. There's different methods, but the cheapest method is usually around $250, and that tells you 18 different compounds, PFAS compounds, and that includes the 6 that will be regulated. That's about how much it costs, $250.
Got it. And is this information like around what the current regulations are and like different pricing on your website?
I don't think so. We're working on that, getting it more to be more advertised better, I guess, because we're mostly a research organization, but we do definitely like to provide testing services to the public, because it's not always available to just contact large companies for water testing.
Got it. I've dropped my email in the chat. If you could reach out, that would be great.
Sure, sure. And
So
we,
did I understand this correctly? So doesn't the city of Wilmington get its water from kind of one source?
the city of Wilmington, I think, is mostly surface water.
Mostly what?
Surface water. So
Surface water?
yeah, they draw from I think red clay and
Brandywine, I'm pretty sure.
yeah, yeah.
Yeah, there's a
Quote me on it.
reservoir that serves Wilmington proper.
Sorry.
There's a reservoir off of 52, and I forget the name of it, that serves all of Wilmington Central water.
Hoops Reservoir.
Yeah, right. And that's probably some of the best water in the state.
Sorry, I'm writing down the email.
Hi, Carly.
Hi.
So can I ask a question, then a follow-up question? So if this gentleman's getting his water from, it's coming from Hoops Reservoir, can somebody from the public contact them and ask them if they've tested their water and get results from them? I mean, is it possible they may already have that information?
Yeah, water companies do test for PFAS.
I know Artesian does. They used to send out a whole brochure with their bills.
Yeah, but they don't have to exactly tell all the details, I guess.
Oh,
Uh,
okay. Okay.
So they may provide you results, yeah.
Okay.
And that would be a way to save money, so that you know what PFAS are in your water.
Yeah. Yep, got it. Thank you.
And then I'm just reading the chat here. You said difficult to clean up, so how do you do it? And I guess you said that on a personal basis. Is that the same industrial? Is that your question, Reed? Am I representing that correctly?
Well, if you can filter them out, but how do you get rid of them? How do you destroy these in general? I mean, whether it's industrial or once your water is tested, I mean, reverse osmosis, does that destroy them or just filter?
No, it only removes them. Reverse osmosis is kind of like a really, really tiny filter almost. So it only lets like basically water molecules through that size compound, and then the PFAS is blocked and goes into like a reject water. And then usually that reject water, it goes to your water treatment facility, just like any other waste in your house.
What if you have a
So, I mean, how do you destroy them?
Um, there's no way for an average person to destroy PFAS, but there's lots of research on like high pressure and high heat to destroy PFAS. You have to basically break it down, but when you break down long chain PFASs, you get short chain PFASs. So it's really difficult to break it down to like the pure fluorine and carbon. It takes a lot of energy to break it down. But there's a lot of research that's ongoing about that.
I guess hence the term forever chemical.
Yeah,
Yeah.
yeah.
There's
Natalie,
a person, Sean Boston, who put something in the chat about his company that is currently manufacturing destruction systems for PFAS.
Yeah,
Um,
sorry, I've just moved to my kitchen. Yeah, we make a couple of systems for way smarter people than me. I'm a mechanical engineer, but at M Davis we manufacture PFAS destruction systems in at least 3 different formats. UV reactors using H2SO3 minus as the active ingredient that is the reactant that will destroy the PFAS chain, lower energy. It's all about getting it to a lower energy because you can break the chain at 1400 degrees C, as I'm sure Jessica will tell you. And again, I'm a mechanical engineer, but then that aerates it. And then you got the whole issue of what they did in that valley in New York where they burnt PFAS at 1400 C and just sent it down a valley. But, you know, basically it's all about low energy. You got to try to do it at a lower energy. So the 3 technologies we work with, UV reactors, gas plasma, I think that one's got a lot of potential. And then there's electrochemically coated membranes. Again, it's, you know, they will break that forever bond. And again, I'm not a chemical engineer, but I am a resident of the area. And like I say, my company, we're a Delaware company and we manufacture for people around parts of America, particularly up in Michigan, where they've got a lot of issues with it. So they're destroying PFAS up there. It's all about trying to do it at a low energy. So, yeah.
What's the name of your company again?
M. Davis and Sons. We're
Okay.
150-year-old Delaware company. So, in fact, one of the reasons why I live in Wilmington now. M. Davis and Sons. We've actually just moved from Delaware to Kennett Square, but you would see our trucks all around the place. So red M and blue Davis and Sons, and we have facilities in Newark as well. And so definitely working towards destroying PFAS for people, and that's why I wanted to join in and listen to what you guys had to say.
thank you.
Thank you.
Is it helpful, Jess and Sean, for you guys to know each other?
Absolutely.
Yes,
I've taken down her website. I'm going to maybe get you to come out and visit our facility, Jessica. I think you'd quite like to see what we're fabricating for people. Companies, Inspired Solutions, On Vector, working with University of Berkeley / University of Illinois.
Great.
Yeah,
That would be helpful. Thank you.
This is the connecting component of this, you know, kind of getting together and just, you know, chit-chatting and finding out who knows what. I just want, Natalie, you've had your hand up for a while.
Yeah, just a quick question. When you use the tool for your own water, you live in Newark and so do I, and I was just curious if you have city water or well water.
I have city water.
Okay, so I have well water, so it would probably be pretty different, or?
Yeah, it really depends on what wells they're pulling from, and if my water is surface water, then depends on what's being released at that time.
Okay, thanks.
Yeah, Newark might be able to provide you with numbers. I'm not sure. Maybe be able to contact them and ask directly.
Susan, you have your hand up?
I do. I searched for my paper from my class on why water is important. And it's how to find your watershed. And it's go wikiwatershed.org model. And then you can go and you put your own address in, and I can see where my water is coming from and where it's draining into. I live in the Hockessin area, but it's different within, a mile, 2 miles. It depends on your house situation.
Mhm.
Interesting. I'm sorry, is that something you could put in the chat, Sue?
Well, I guess I have a whole paper here on how to do it, what to click on and all, and get started. And I wanted to do it and print out my own watershed here. I can put the website in the chat. But
Okay.
Jessica, have you heard of this watershed model?
Yeah, I think I have used it in the past. Are you looking for it to understand your well water?
I don't have well water. I have whatever water. And my class is going to take a field trip on Concord Pike somewhere, the pilot school, to see some water place there.
Okay,
Field trip.
nice.
So yours, did I get this right? So yours tests the water, is that right? And just the one you had tested what's in your body?
So the tool I think Susan was talking about, it displays kind of like if rainfall falls in your area where the water will go,
Yeah.
like your watershed. The tool I was showing estimates your PFAS content in your blood based on your drinking water.
And why we have retention ponds now in all the communities for this water to go to.
But you're not gonna necessarily, unless you have groundwater like a well, then your watershed it should be based on your your public water supply PFAS content or your well water content for the tool.
James, I'm just going to answer your question. You said, is this presentation available? In the beginning of the chat, Dee noted that it's on a YouTube recording with Green Drinks, and there's the website place to get this recording. Okay.
Thanks, Jill. I wonder if he is looking specifically for the PowerPoint itself, if we can send that out, maybe, if Jess would
Okay.
let us.
Can we have the PowerPoint, Jess?
Oh, yes, sorry, I missed your question. I was reading the comments.
It's hard to read it.
Yeah, I'm sorry.
Sharon, did you have a question? You have your hand up?
Yeah, actually, it's a question that's already in the chat. Somebody asked if waterproof sunscreens, do they typically contain PFAS?
I can't say for sure
Yeah.
that they do. But if you did some Googling, there might be some research on that.
Okay.
Yeah, I'm not really sure. I can't say for sure. But
Okay.
there has been research on waterproof mascaras and foundation, things like that. So
Yeah.
there have been some research on sunscreens as well.
Yeah. Okay. Thanks.
Mhm.
Anything else in the chat that I'm missing here? Whoopsie, oops. Did I just, no, I did not. Okay.
Um,
Thank you for posting that, Sue. Any other questions?
I have a question for Norma. She said she had
Yes.
tested her water for $80.
Yes, Cyclopure. I just looked it up. It's called, it's spelled C as in Charlie, YCLOP as in Paul, URE. And this site was, or outfit was recommended by the law firm that's handling the case, the Gore lawsuit, the class action suit of which I am a claimant,
And
and that's how I found.
Sorry.
I'm sorry.
Is that the test that you run under your tap water and then send back only the filter?
No, they send you a container and then you fill it up with, I don't know, 2 or 3 ounces of water. And in my case, since I have a spring house, I could go down and climb into the spring house and get the water there if I want to get it before it go. I do have a water softening system. Or you could just get it out of the faucet because that's, you know, what you're drinking. So that's actually what I did, was get it out of the faucet and I sent it off, and then it was either $60 or $80.
Okay.
And it came back. I have 4 different compounds in my water.
And did it give you, how many different types of PFAS did they tell you were detected or were looked for in your water?
I would have, let me see, I would have to look at the report that they sent me, because I don't remember.
Okay.
It was maybe 10 or 12. I'd have to
Okay.
pull it up and look at the actual report that they sent back.
And
Looks like their website says 55.
their website says 55.
Mm-hmm.
Okay.
Oh.
I don't know if this is the actual test, but I'll put it in the chat.
Thank you, Phil.
Did they say what their detection limits were? Like how low they can detect PFAS to?
They use EPA method 533, 537, and 1633.
Okay. Oh,
Using HPLC, HRMS mass spec.
okay.
Yeah, that's Cyclopure is the cyclodextrin people. They have their own cleanup product that they're marketing. So perhaps they find it beneficial to give people a good price.
Yeah.
Could be.
That's way more than good price. I think that's very competitive pricing. Just to let everyone know, the cost of running a PFAS lab is very expensive, because the compounds that we use to measure the PFAS in water, to base our concentrations off of, are very expensive, our standards. So that's why the cost is so different.
Tom, you had a question in the chat. You want to just say it out loud? Or I'll read it.
Yes, sorry. The state provides free water testing for well owners. Do they test for PFAS?
No, I saw that on the website. It's very confusing because I mentioned that at the bottom after discussing PFAS. But if you click the link and follow that, they only test for free for like specific compounds like nitrogen and phosphorus, the normal drinking water tests.
Okay, thanks.
At least in Delaware, if that's what you're referring to.
It was, thank you.
Okay.
Any other questions or comments or thoughts? Well, Jess, thank you.
Thanks for having
Thank
me.
you, thank you, thank you. Just really, really dynamite, dynamite, dynamite. Tons and tons of information. I know I learned a ton. I think there were some good connections made. And once again, thank you to the Steve and Audrey Like for connecting us up to you. And thank you. I thank you all for coming along, and hope to have you all listen to Phil Smith and his wonderful, nice British accent next month, talking about the MIT program that can show you what things really change and reduce climate change. So we will see you all back then. And I think we got everything. Dee, everybody knows about Yes for high school students. Any other announcements that I've missed along the way? Everybody got their thing out there. So thank you all for coming, and thank you again, Jess, and we will see you all next month on, March 18th. That seems so far away. So happy spring.
Thanks for having me.
Thank you,
Thank you.
Jess. Thanks, everybody. Good night.
Good night.
Bye. Good night. Thank you.